Hello everyone, I am Mohammed Rahman, a mechanical engineer, and I've created this channel to showcase the works of my company, to showcase the engines that we're working on and the cars that we're working on, also to showcase our solutions for sustainable energy homes. So please subscribe to this channel, alright? And for today's video, I just want to do a short discussion on the principle of batteries and range. But I'm going to try to do it in a way that anyone should be able to understand, or at least anyone should be able to follow the discussion. All right? So, our basic principle of technically all batteries came from the voltaic pile. And this was an experiment performed by Alexander Volta in the 1700s. And what he did was basically pile two metal plates together, separated by a cloth soaked with salt water, like so. And the metals he used were silver, which serve as the positive or cathode, and zinc, which serve as the negative section, or anode. And the cloth serve as his electrolyte. And then he connected a wire to both plates to form a closed loop. And he noticed that when he connected both plates with a wire forming a closed loop, electricity was generated. And we know that electricity was generated because of the chemical reaction that occurs within the negative section, the zinc and the electrolyte, which cause an electron buildup within the negative section of the experiment, and also which cause a potential difference or voltage between the two plates. And the wire that he connected to both plates causes the electrons to flow between the two plates. You see? So basically, this is the basic fundamental principle of technically all batteries. And since then, engineers and scientists have been, trying to modify this basic design, using different materials and different metals to have better batteries. So engineers and scientists have been modifying this design so we can have, again, using different metals and materials, so we can have better batteries with less weight, high density, and high capacity. And over the years, for example, alkaline and lead acid batteries had been the dominant types of batteries. And of course, now we are moving towards lithium ion batteries. And also, I've seen the research on solid state batteries. But again, every single one of this type of batteries have exactly the same principle as with the voltaic pile experiment. And again, these are just engineers and scientists trying to build better batteries using different materials, so we can have batteries, with lightweight, high density, and high capacity. So how do we determine the capacity of a battery? Well, capacity is simply the voltage multiplied by the current. So for example, let's say if we have a 2-volt battery, a 2-volt 100 amp battery, and then the capacity of this battery is simply 200 amp hour. You see, and let's say also, for example, we have, in our house we have a light bulb, and let's say this is a 50-watt light bulb. That this simply means that, for example, this battery can power this light bulb for 4 hours. You see. Also, another thing, normally when we are dealing with applications that requires high capacity, we normally use 200 watt hours. And when we're dealing with application that requires high capacity batteries, we normally use kilowatt hours instead of watt hours. So for example, 1 kilowatt hours, 1 kilowatt hour battery is simply just 1,000 watt hours. Okay. So how do we determine the range? Well, for this, let's do a simple example, a simple, hopefully straightforward example. And let's use a normal sedan. And let's say this is a car that weighs 3,500 pounds. And let's say we are able to design or build or obtain a battery pack, and let's say this is a 20 kilowatt hour battery pack. So what would be the range of this design or of this car? Well, to do this, let's look, or let's see if we can modify the range equation. And the range equation is simply the capacity divided by watt hour per mile. You see? But we know that watt hour per mile is simply the weight of the car divided by 10. So now we can use this in our equation like so. Capacity now is simply just range equation. The range is simply the capacity divided by the weight divided by 10. And we can clean this up a little bit like so. So now our range equation becomes capacity over weight multiplied by 10. You see? So now, again, to determine the range, for our example, we simply just plug in the numbers. And we say the capacity is 20 kilowatt hours. And we said the weight of the car is 3,500 pounds. and this gives us a range of 57.1 miles. All right. Oh, another thing also, it is advised or it is recommended that, for example, if we are using a lead acid battery, it is advised not to use more than no more than 50% of the capacity. So we simply just multiply your solution by 0.5. And if you are using a lithium ion battery now, it is recommended not use to use no more than 80% of the capacity. So you simply just multiply your solution by 0.8. All right. And lastly, I would like to mention that even though for this application we simply use the weight of the car and the capacity of the batteries, but when engineers are designing a car from scratch, these are not only the two considerations. But for my DIY community now, going through this process, with only this two considerations should give you a pretty reliable solution. All right. So basically, that's all I want to discuss for this video. And again, please subscribe to this channel. And thanks for watching and thanks for listening.